Thank, thank you so much. I think thank you for inviting me to this great event. So I'll take a step back and we'll have to complete in 10 minutes, right? So Sarah said. Probably I'll try to answer why we need AI today in the industry or even in the academia or for that matter even in our life. So actually we are living in the golden era of technological revolution. And recently we are actually moving from digitization to cognification. And now I'll explain what is cognification because you will not find this word in the Oxford Dictionary. So cognification is a process wherein we bring the human cognitive element into our digitization process. So today if I ask you, is there any physical services left which has not been digitized? I think you will have a hard time to answer. Now in this age of extreme automation, what we are trying to do is we are trying to bring the human cognitive element into our automation process or digitization process. And to do so, I think AI is one of those technologies which is helping us a lot. So when I say AI actually is an umbrella term, right? AI has no meaning, essentially, if you look at. So it is kind of a term that has been used for a lot many technologies under that. So under AI, if we draw a big circle, so that is AI. So this entire subject is actually cognitive science. Under AI, there is a subvertical called machine learning, which is essentially mathematical models or statistical models. So inherently, I'm being a scientist, inherently there will be some technical things coming up, but bear with me, I'll not go that technical. And under machine learning, there is another subvertical which is called deep learning using neural networks. And the entire hype around AI that you have seen in the last 1 decade is not because of those mathematical and statistical models, but because of neural networks. Just to give you an example how neural network works so that I think it will set some context on that. So let's take our visual system, how our visual system works. So if I see at an object or a person, so light rays from that object comes to my eyes, okay, it goes through the retina, and straight away it falls into something called visual cortex. The main function of visual cortex is essentially transform the light photons into electrical signals. So light signals are being transformed into electrical signals. And after that it falls into the different layers of neuron. Okay, and as you all know, in a human brain, there are 100 billion neurons. And these neurons are very special kind of cells. First of all, it is a little bit bigger in size compared to the other cells in the body. Also, it is minus 50 microvolt negatively charged than the surrounding. Okay, that gives a little bit of potential difference in the cell. Now, when this electrical signal falls into these neurons, a very special phenomena happens, which is called protein synthesis. It is like photosynthesis in the leaves. And these neurons are actually work in a threshold mechanism. So when the potential increases to a particular level, this electrical signal is being fired from one neuron to the next layer of neuron, and there is a connection where like a structure which is called synapse. So actually it passes the information from one neuron to the other neuron. So in that way, the information is processed, say probably millions of layers of neurons, right? And finally, it goes into a decision-making layer, okay, wherein a prediction or a decision has been made, right? So for example, if a child, for the first day, he looks at an elephant, right? So the same light rays from the elephant goes through the eyes of that child to the visual cortex, okay, and falls into the neurons, and multiple layers of neuron it crosses, and ultimately it creates a elastic image of that elephant. And when I say elastic image, it is like foldable. So it is an image that can be folded, right? So now this child doesn't know what exactly is this. Then he asks his father, who is standing near to him, the dad, what is this? His father says, this is an elephant. At that moment, this elastic image has been tagged as an elephant in his brain. The same process we are trying to do in semiconductor using some mathematical formulas. So here also what we are building artificial neurons. And also we are giving the threshold function, which is called activation function. So many people who are there in the engineering, they already know that. So now you can imagine a neural network which is trained with huge amount of data. For example, we have seen last decade, it can be attributed to a neural network which is called CNN, convolutional neural network. So anything and everything that you see in the space of image recognition, identifying an object in the image, reading the number plate of your car, well, car is crossing 80 miles per hour limit, everything, video analytics, everything is being attributed to CNN, convolutional neural network. But we were missing one thing which Sir was telling and rightly identifying: language. Language is one of the most difficult thing in this world, because the same thing you can say in many different ways. So then came a neural network, which is called RNN, recurrent neural network. But again, this neural network has also some problems. Okay, it has got some fundamental problems called vanishing gradient and exploding gradient. So how an AI model learns is like a child. The child, the first day, you cannot give him an MSc book to him. He will not be able to understand. He will have to learn from ABCD to 1, 2, 3, 4 till undergrad and then MSc. Exactly the same thing is applied for the machine also. Any machine learning model, if it is like pretending to learn like this, which is called exploding gradient, that means it is actually pretending, but it is not learning anything. Okay, some smart child do the same thing, right? Similarly, the vanishing gradient is a problem when child is like a dull. He is not at all learning, right? Then we came up with another model, and I think in this room, most of you have used this model, okay? The most, 90% of your time when you were there in the internet. That is called LSTM, long short-term memory. In the Google search, Google Translate, whatever you are doing, any kind of text processing, any kind of things, it is under the, behind the scene, LSTM. But still the problem was not been solved, because LSTM can be trained to a certain extent. After that, LSTM becomes so bulky that when you ask any question to the LSTM, it cannot produce the answer to you on the right time. Then came a revolutionary paper from University of Toronto and some of the Google scientists. And whatever revolution that you see in the area of generative AI is essentially because of this research paper. And this research paper, they developed a neural network called transformer neural network. This transformer neural network are the heart of ChatGPT, Google Bard, or any other model that you see. It is not only on the language domain. Generative AI can generate image, generative AI can generate video, it can generate audio, anything and everything. I don't know tomorrow what it is going to generate. And there is another research paper, which is again a revolutionary research paper called Attention That All You Need. These together frame these large language models, LLMs. What happens when a model is trained with billions of parameters? So ChatGPT 3.5 is trained with 175 billion parameters. GPT-4 has been trained with 1.7 trillion parameters. Now think of the amount of data. It is all the wiki articles that are available in the internet, all the research papers published by the universities, all the social media interaction that you have done, okay? It has been trained with everything. Now it creates a memory map within that. So it understands history, geography, science, physics, quantum physics and everything, right? But the problem is when as a user, I am firing a query to that model, how it can generate the answer within a couple of seconds. That's where the attention model or the attention that all you need, this revolutionary paper came into picture. And Google and OpenAI has developed this. Now to summarize this to the job context or the context of how we will be living in this age of AI, what I would say is let's be very honest. First of all, AI has already started eliminating many jobs. Let's be very honest. But from our past experiences, what we have seen in industrial evolution 1.1, 2, 3, even 4, that in short term, it eliminates some job. But in long term, it generates more jobs. And what it does is basically, it elevates the job roles, right? So probably we're doing some mundane job today. Tomorrow, probably we'll be doing some other job. So what we need to do is, we need to be ready to be adaptive, first of all, adaptive to the situation or the scenario that comes in front of us. Second thing is continuous learning. So your 4 years degree or a 6 years degree will not be enough for your lifelong employment. If you want to be employed lifelong, you will have to learn lifelong. I think with that, I want to close this. Thank you so much.